Hi viewers, welcome to our channel Math and Math. So let us solve a CSI and net problem. This is a part B question, only one of the option is right. The question states, let U, V, W be 3 points in R cube not lying in any plane containing the origin. Then 4 options are given. The first option is alpha 1 U plus alpha 2 V plus alpha 3 W should be 0. That implies alpha 1 equal to alpha 2 equal to alpha 3 which is equal to 0. The next option says U, V, W are mutually orthogonal. The next option says one of U, V, W has to be 0. The other option says U, V, W are pairwise orthogonal. So here for solving this problem, let us consider U, V, W 3 points randomly and then check these options. Okay. Let us consider U to be equal to 1, 2, 0, V to be equal to 2, 1, 0 and W to be equal to 3, 2, 3. So when you see this U, V, W, here itself we can make out that none of U, V, W are 0. So when do you say that it is 0? U, V, W, any one of them should be equal to 0, 0, 0. That is not the case which we had considered. So therefore, U, V, W, none of them are 0. So one of the options is neglected from this. Then let us check for orthogonality. So when do you say that 2 points are orthogonal? When you have the dot product of 2 points giving you 0, then you say it is orthogonal. Let us consider U. 1, 2, 0 dot product with 2, 1, 0. If this is giving us 0, then we will check for the other points, other combinations also. Let us check with this. 1 dot U dot V, that is 1 into 2, that is 2, plus 2 into 1, that is 2, plus 0 into 0, that is 0. This gives us 4 and this is not equal to 0. So therefore they are not orthogonal. They are not orthogonal. So this is not orthogonal. U dot V is not giving us 0, so it is not orthogonal. Similarly, you can check for all the other combinations, that is V dot W and U dot W, all the other combinations. So they are not going to be equal to 0. So logically, if you see the considered points, they are all positive. So whenever you take the dot product, obviously you will not get 0. In case if you have negative values, then there is a chance to get 0. Here none of them is negative. Obviously they will be positive when you add it. Therefore you will not get the dot product to be 0. Hence we can say that U, V, W are neither mutually orthogonal nor pairwise orthogonal. So in our options we had these points, that is U, V, W must be orthogonal and they are pairwise orthogonal. So 3 options, that is option B, option C and option D, they are all incorrect. So option A has to be correct. Anyways, let us also check for that. That was alpha 1 U plus alpha 2 V plus alpha 3 W equal to 0, which had implied that alpha 1, alpha 2, alpha 3 are 0. Let us check for that. Alpha 1 into U was 1, 2, 0. alpha 2 into v2 comma 1 comma 0 plus alpha 3 into w 3 comma 2 comma 3, which is equal to 0. So multiplying with respect to each of the coordinate, what do we get? Alpha 1 into 1 alpha 1 plus 2 into alpha 2 plus 3 into alpha 3, which is equal to 0. With respect to the second coordinate, we get 2 into alpha 1 plus 1 into alpha 2, that is alpha 2, plus 2 into alpha 3, which is equal to 0. Finally, 0 into alpha 1 plus 0 into alpha 2 plus 3 into alpha 3, which is equal to 0. So now from these equations, from this last equation, we can say that 3 alpha 3 equal to 0, that implies alpha 3 is equal to 0. Okay, so alpha 3 is equal to 0. So substituting in these two equations, say 1 and 2, what do we get? We get alpha 1 plus 2 alpha 2 equal to 0 and 2 alpha 1 plus alpha 2 is equal to 0. So let's multiply this equation with the 2 and simplify them. So when we multiply this equation with 2, we get 4 alpha 1 plus 2 alpha 2 equal to 0. The other equation, let me name this as equation 3 and this as equation 4. So let me consider equation 3 here, alpha 1 plus 2 alpha 2 equal to 0. With subtraction, this goes to 0. So I am left out with 3 alpha 1, which is equal to 0. So that implies alpha 1 is 0. Substitute this alpha 1 equal to 0 in either equation 3 or in equation 1 or 2. So from equation 3, what do we get? 2 alpha 2 is equal to 0. This again implies alpha 2 is equal to 0. So on all these simplifications, we got alpha 1 is equal to alpha 2 is equal to alpha 3 is equal to 0. So therefore, if you check for the first option, alpha 1u plus alpha 2v plus alpha 3w, this condition, this star condition implies us alpha 1 is equal to alpha 2 is equal to alpha 3 is equal to 0. Our option A has to be the correct option. This is the correct option. Let us try solving few more examples in our next videos. Thank you.